Okay, welcome back, everybody. This is the practice test of Unit 8. So let's go ahead and get started with this one. Here we begin off with sigmas. So let's set this up in knowing how to deal with sigmas. So we have a sample average of 3.55, sigma of 0.28. Again, this is the determining factor on how we do this problem. The sample size in this case is 17 birds, and we want a confidence of 80%. So we go ahead and turn that into a ZC. So for that, we need that Z box thing. So the 80% is 1.28. So this is going to be 1.28 in this particular problem. Then we can go ahead and work on the margin of error in this situation. So the margin of error is ZC sigma divided by the root of n. Again, the sigma is the thing that tells us that this is the equation that we're going to be using. 17. Uh, 0869. Oakley dokley. So we're talking about really light birds, so you're not going to see that big of a difference. So a confidence interval is the sample average minus E is going to predict the population average. Again, that's to the sample average plus E. So our guesstimate is the X bar, but we know it's wrong, so we put on this error factor to it. So 3.55 minus E and then we go to the top limit by the sample plus E. There it is. Okay, now we're talking about profits per employee. So I don't think they provide us with an X bar, so this is the hardest part of the problem. So let's go ahead and set that up if we can. This is not the same stuff, so let's go 42.5, 42, 47.8, 60.1, 53.8, 55.1, 54.5, and 42.7. Okay, scroll through that just to make sure I didn't make a boo-boo somewhere. Boop-a-doop-boop-boop. Okay, it looks all good to me. So I calculate one var, and I see that my sample average is 49.8125. Okay, use the standard deviation that they provide of 6.5. Don't take it from your calculator. The sample size in this case was 1, 2, 3, 4, 5, 6, 7, 8, and it's also verified up on my calculator, 8. And then I want a confidence of 75%. So that 75% is going to tell me that my ZC is 1.15. Okay. Off and running. Now we can go ahead and find that E, the margin of error, E is equal to ZC sigma divided by the root of n. So this is going to be 1.15 of sigma divided by the root of n. So that is 2.6428. onto the confidence interval. Sample minus E is the prediction of the population average to the sample plus E. So in essence, again, what is happening is X bar is our guesstimate of what this average is, and then all we do is we add an E and we subtract an E. So E is in essence determining the length. The bigger E is, that means you subtract more and add more. If E is real small, then it'd be really short. Okay. We'll get into that in the next question. Let's go ahead and complete this one. So X bar minus E and then X bar plus E. X bar plus E. There it is. All right, so what happens if we change the confidence? So right now the confidence is at 75%, which is a ZC of 115. So if I turn this into a confidence of 90%, which has a ZC of, I believe it's 1.645. So 90%, 1.645. I just saw that my ZC just got larger. Okay, my ZC just got larger. So that is going to affect the E. That's where the ZC is used. It affects E. So E in this situation is ZC sigma divided by the root of N. And so ZC just got larger. ZC is a multiplication number. So if I multiply by a big number, my answer is also going to get big. So the E is also going to get larger. And so how does that affect the confidence interval? This is what the question was asking. And as I was kind of alluding to before, E is the determining factor of the length. If E is big, my interval is long. If E is small, then my interval is short. So here, E is larger. So E just got larger. So what does that affect this length? It just gets longer. Okay. And then the last one is what type of average is 53? So I see 53 is above the 52. So this is going to be above average. Because 53 is above the largest average of 52,4553. Okay, last but not least, another confidence interval, X bar, standard deviation, sample size, confidence. Because it's a sigma, we are using a ZC. 95% is 1.96. So error is ZC sigma divided by the root of N. 2.1343. All right, so to the confidence interval itself now, which we take the sample minus our average, and that's going to be our prediction of the actual average, the sample plus E. So we take X bar minus E and my sample plus E. There it is. Okay, the next competency is dealing with S's. So we're going to have to change things up a little bit. So we begin with the hypothetical problem. And so we want a confidence interval that is shorter. So the confidence interval is still X bar minus E, X bar plus E. And we want our confidence interval to be shorter. So if that's the case, what does E need to be? Well, E needs to be smaller. I want that to be shorter, smaller. Larger, longer, shorter, smaller. And so, well, what does that have to do with N? So E is just going to get smaller. So in this case, because sigma is not known, we are going to be using this formula, and E just got smaller. So how does that affect N? N is a division number, so it's going to be opposite. So if we are shorter, N is going to get larger. And so if I have a decision to make between an N of 18 and an N of 24, N would obviously be 24. Okay, on to the actual confidence intervals now. Here we have an average of 89.6667, standard deviation, that is an S, 31, 38, 58, a sample size of 1, 2, 3, 4, 5, 6, and a confidence of 80%. All right, because this is an S, I need to get a degree of freedom, which is 1 minus the N. So my degree of freedom here is going to be 5. And then that means I need to get a TC. So a confidence of 80%, degree of freedom of 5. So 5 at 80%. Let's take a look at that T table, 5 at 80%. So degree of freedom of 5, 80% is 1.476. Okay. 1.476. So now everything is pretty much the same as it was before, just technically a different equation. Same but different. Notice how the N is still 6. It did not turn into 5. The degree of freedom of 5, N is still 6. All right, so X bar minus E and X bar plus E. Okay, good. All right. So here we have an average of 44.4, standard deviation of 23.7168, a sample size of 2, 3, 4, 5, 6, 7, 8, 9, 10, and a confidence of 95%. Because it's an S, I need to get my degree of freedom and my TC. So this is 9 at 95%. So 9 at 95%, 2.262. Whoa, sorry, let's try that again. That's a little bit better. Okay, so X bar minus E. And X bar plus E. All right, so that's it for averages. On to the probability problems. Okay, suppose you want to conduct a survey and the proportion. So we're talking about probabilities here. So let's go with the margin of error. How does decreasing the sample size affect the margin of error? All right, so the margin of error. And decreasing the sample size would be the N. So how does that affect the margin of error? So N is a division. So it's going to be opposite. So if N gets smaller, decreasing the sample size, that would increase the margin of error. All right, so here we go with probabilities. So I see that the N in this situation is 517 judges. The number of introverts are 284. So that means P hat, which is R divided by N. Again, it's going to be always the small divided by the big here, is 5493. That means Q hat, again, that's opposite of the P, is 4507. Try to write down the wrong number here. Try that again. And I see that I have a confidence of 99%, which is a ZC of 2 point something something. So 99%. 99%, 2.58. Ogly doggly. So true error, margin of error, which is ZC, P hat, Q hat, and so how I begin this is I begin with the P hat. Divided by N, and crazy small number. So I begin with 5493 times 4507 divided by 517. Okay. Then to that, I square root that answer. And then I multiply by 2.58. All right, so the confidence interval in this situation is going to be P hat minus E is less than P is less than P hat plus E. Make sure you use the right symbols. Okay, AKA use P's, not mu's and things like that. So P hat 5493 minus and plus. Okay, give a brief interpretation. Begin with the confidence. Give the middle symbol. This is a P, so that's a probability. Otherwise, it'd be the word average. Notice how it's the word probability, not proportion. I know it says proportion up above. You must use the word probability. Next, use the context in the singular sense. So we are talking about, I believe, judges who are introverts. So that would be a judge being an introvert. And then go ahead and give the confidence interval. Notice how the P is in between. Read it once. We're 99% confident that the probability of a judge being an introvert is between 0.4928 and 0.6058. All right, it makes logical English sense. Okay, last question. We have no preliminary estimate, we have a distance, and we have a confidence. All right, so the no preliminary estimate implies that we are using the minimal sample size of 1/4 of ZC divided by E squared. All right, so with a confidence of 85%, that alludes to that the ZC is 85% is 1.44. And then the distance from the actual average is 7.5%. All right, so that means E is 0.075. Okay, that's what E is. So we go ahead and plug in Chug. So again, ZC is 1.44. Distance is 0.75 squared. So you need to have 92.16 things, or AKA 93.